In this video, we're going to be testing to see whether a relationship between two variables, the y and the x, whether that relationship is indeed a function, focusing particularly on whether it's a function of x. But to begin with, we need to define what a function is. Now, the definition that we're going to be using here is a function of x is where for any one input of our x value, there is only ever a maximum of one output for our y. So let's go over what this means for our graphs here. So starting with our linear relationship that we have here between our y and our x, what we're really testing for is for whatever value of x that I input here, how many values of y are there on my graph? Now to do that, I can use what's known as a vertical line test because I've got the graph here. So if I input this negative value, let's say this is negative 100, over here on my graph, probably isn't negative 100 when I think about it, but let's just say that. How many solutions are there for that value? Well, on our graph here, you can see here that it only cuts through the graph once. So that has one y output. So far, so good. If I put, say, this value here, this negative value of x here, it only intercepts the graph once here. So it's only got one y output. If I was to put x equals 0 in, so that would be the y-axis, it only has one y output, and that y output's here, and we know what that is, it's positive 2. If I was to put positive 10 in, let's say that's over here somewhere, we can see that it's got one intercept. And you can start to picture that no matter what vertical line here, no matter what value of x that I put in, I'm only ever going to get one y value as my output. Where if we compare this graph down here, this graph of x equals y squared take 1, if I put one input of x in, let's see how many y outputs that I can get. Let's start with, say, putting negative 10 in as my x. My x equals negative 10. You can see here that on my graph here, it doesn't have any solutions. So for that input of negative 10, for my x, it's got 0 outputs. That in itself doesn't prove that it's a function yet. If I look at putting x is negative 1 in, so that will be right here, where the x-intercept is, you can see here that it has one output for our y. So far it's still fitting our definition of a function. But what if I put x is positive 5 in? So something over here. Well, what you can see here is it's got an intercept here. It's got a y output that's here, and it's got a second one down here. So it's got a second y output. So at that point, we can see that when we put one value of x in, it's actually giving us two outputs or two solutions to that value of x. At that point, this equation cannot be represented as a function of x anymore. And the reason for that is it's got two outputs or two solutions for my one input of x. Now, to summarize, a function of x is for any one input of our x value, there is a maximum of one output for our y. And one test that we can use for this is we can look at the graph and do what's known as a vertical line test. And to put vertical lines through our graph and see if at any point on our graph, is there more than one intercept? If there is only ever a maximum of one intercept, it is a function of x. However, if we can find a point where there's more than one intercept to our vertical line test, it cannot be represented as a function of x.